Good morning, students. Prushish are back with a new interesting problem, very useful for your entrance examination point of view. The topic is friction. Friction force. It's an interesting problem. Okay, this type of questions have been asked in various fora, various examinations. Many of you might have come across this also. But let us say let us discuss a more generalized way of dealing with this. And as you know, these are my credentials. All of you must be knowing by now. Let us come to the topic. I am discussing today a very interesting question on friction forces acting on the bodies connected by a light inextensible string. Just see the figure below, the diagram below. This string is light, means massless, inextensible string placed on a horizontal surface. These two blocks connected by a massless inextensible string placed on a horizontal surface. External driving forces acting on them, F1, F2, they are driving forces. Driving forces means what? They are those forces which will cause them to change the state of motion. Okay? See the diagram below. Okay, the driving forces are underlining also. F1, F2 are driving forces. Mu1 is the coefficient of friction between block that M1 and floor. Mu2 is the coefficient friction between M2 and the floor. That different coefficient of frictions. Maybe the surfaces of the two blocks are different from each other. Okay. This is the horizontal rough surface, F1 acting horizontally on the block 1, that is M1, and F2 is acting on the block 2, that is mass M2, also horizontally, as you see. So the small f1 and small f2, these external forces, the driving forces, capital F1, capital F2. The small f1, small f2, as you see, I have shown here, they are the frictional forces acting on M1, M2 respectively. Okay. Okay. Find. So the question is, determine F1, F2 acceleration and tension in this string. Okay, discuss all possible cases. This is a question. F1, F2 acceleration, tension in this string. तो अभी हम उसको सॉल्यूशन करेंगे. डिस्कस ऑल पॉसिबल केसेस. तो सॉल्यूशन में क्या रहेगा? Before discussing cases, let me write what is the maximum friction force on M1 and M2. That is mu1 M1G and mu2 M2G, the maximum friction force F1 max and F2 max. Here I am not distinguishing between static and kinetic friction here. I am not distinguishing. Net driving force which causes motion, that is F1 minus F2, as you can see in the diagram. Case 1, F1 minus F2, the net driving force is greater than the sum of maximum friction forces. then obviously if F1 minus F2 is greater than F1 max and F2 max, then the M1, M2 along with the string will start sliding to the right. Okay. So acceleration of both blocks will be A. A is F1 minus F2 minus mu1 M1G minus mu2 M2G by M1 plus M2, which will be greater than 0 because this F1 minus F2 is greater than sum of these two friction forces. So what is in this case, what is the friction force? F1 is F1 max, F2 is F2 max, and tension will be, just go to a single body, tension force will be F1 minus, that is F1 minus tension minus F1 max will be mass into acceleration. So you can write this. So Ft will be F1 minus mu1 M1G minus M1A, because I'll write here F1 minus T, or let me write in later, change the let me write in bracket F1 minus T minus mu1 M1G is equal to M1A. So this implies T is equal to F1 minus mu1 M1G minus M1A. So F1 minus M1 common, mu1G plus A, and A you can replace from this value. Replace from the A, value of A can be replaced from here. So you will find that finally M2 F1 plus M1 F2 divided by M1 plus M2 minus mu1 minus mu2 into M1 M2 by M1 plus M2 into G. This is the acceleration. This is the tension. Acceleration is here. F1, F2, they are maximum values, and tension I found out like this. This is a very simple case. This is the simplest case. Case 1 is the simplest case. You may say, why you cannot cancel? Can you calculate tension from this body? Definitely we can do that. Obviously, T minus F2 minus F2 max is M2A. From this you can calculate. That's what I wrote. We can also calculate tension T from T is equal to F2 plus mu2 M2G plus M2A. Am I clear? Because T minus F2 minus mu2 M2G is M2A. So bring F2 and mu2 M2G to the right, so get T. If you put this way also, get the exact same value of tension as I got here. So this I did not do much because all of you must be knowing this free body diagram and all this. So this tension, if you mark here also, this is tension, you can solve it. Okay. If F2 is greater than F1, they will accept like this. But F2 minus F1, it has to be greater than the total maximum friction force, then only acceleration will happen. Otherwise, there will be no acceleration. If that happens, this is a very simple thing. Now, case 2, a bit more involved cases. F1 minus F2 magnitude, either to the right or to the left, is less than sum of maximum friction forces. Then there will be zero acceleration because net driving force is less than the total maximum friction force. In this case, F1, F2, T all may be greater than 0, even acceleration 0, but F1, F2 and T all may be greater than 0, or some of these, but not all. may be equal to 0 also. Okay, this A is 0, then remaining 4 all may be greater than 0. Otherwise, out of these 3, not all, but some of these 3 may be equal to 0, but not all. Not all, definitely not all. As long as this condition is satisfied. तो केस 2 के अंडर में और 4 केस में डिस्कस कर रहा हूं. 1, let us consider all the sub cases. 1, F1 less than maximum friction force on the block 1 less than equal to, and F2 also less than equal to maximum friction force on the block 2. In this case, since F2 is not able to overcome the maximum friction force, F1 is not able to overcome the maximum friction force. So this friction force will be simply capital F1. T will not come into picture. And friction force on the 2 also will be capital F2. Simple as that. Because unless the F1 or F2 exceed the maximum friction force, the pulling will not happen. Okay, here what we have assumption here is that the blocks have been kept on the surface. After that, the forces are being applied starting from 0 to increasing to the respective F1, F2 values. Okay. We can write this as forces applied after placing the system on the floor. Okay, fine. So केस 1 खत्म, जिसमें एक्सीलरेशन होगा वो तो हम खत्म कर दिए. देन केस 2 में फर्स्ट केस, उसका जो सब केस है वो भी क्लियर हो गया आपको. उसमें देखो F1 F2 दोनों नॉन जीरो है, बट T 0 है. आई टोल्ड ऑल में बी ग्रेटर देन 0 or some of these, not all, may be equal to 0. In this case में एक 0 T 0 है, बाकी दोनों greater than 0 है. केस 2 में देखेंगे F1 is greater than mu1 m1g but F2 less than equal to mu2 m2g. अगर F1 greater than mu1 m1g है तो it will exceed that maximum friction force and it will start pulling the string. So F1 will be go to the maximum value mu1 m1g, direction of F1 opposite to F1, capital F1. T will be F1 minus mu1 m1g because there is no acceleration term, because I am discussing case 2. Okay, acceleration 0. Okay, so T is F capital F1 minus mu1 m1g. Friction force F1 is mu1 m1g, that is reaching the maximum value, then tension developing. And then small f2, that is the friction force on the other block, will be equal to magnitude of f2 minus t. Direction of f2 is decided by the magnitude of f2t. If t greater than capital F2, then it will be in the direction of f2. If f2 is greater than capital T, then friction force will be opposite to capital F2. Always it is opposing the impending relative motion. Okay, that you can find out after putting out numerical values. Then the same case, F2 greater than mu2 m2g but F1 less than equal to mu1 m1g. So whatever I discussed, same thing I am doing starting from block 2. then F2 greater than mu to M2G means the friction force on block 2 on the block 2 will reach the maximum value and direction will be opposite to capital F2. Tension will be similar, just like this, it will be F2 minus mu to M2G, because after that pulling starts. Then F1 will be the magnitude of F1 minus T. Direction of F1 is decided by the magnitude of F1 and T. Okay. If capital F1 greater than T, then friction force will opposing the capital F1, or T is greater than capital F1. So friction force will be opposite to the T direction, in the direction of capital F1. Okay. The three subcases. Now, fourth subcase is most critical. Fourth subcase under the case 2. Case 2 is what? The net driving force is less than the total maximum friction force. Okay. The most critical case is the subcase 4 under the case 2. No acceleration anywhere we know. So F1 greater than mu1 m1g and F2 greater than mu2 m2g. Both are greater than mu1 than respective maximum friction force of those respective blocks. In this case, how to calculate the small f1, small f2, anyway acceleration is 0 and tension T. So इसमें in this case compare the values of f1 minus mu1 m1g and f2 minus mu2 m2g. F minus mu mg value for m1 and F minus mu mg value for m2 you compare. So compare में कितना केस होंगे? 3 केसेस होंगे. ये ग्रेटर हो सकता है उससे, लेस हो सकता है उससे, इक्वल हो सकता. तो केस ए में F1 minus mu1g mu m1g greater than F2 minus mu2 m2g. So whichever F minus mu mg value is greater, that will have a more tendency of pulling, or that means that friction force small f1 will reach the maximum value. So F1 minus mu m1g is greater than F2 minus mu m2g under this condition. So if it is greater than this, this will try to reach the maximum friction force, and before this reaches maximum friction force. So since this is reaching maximum friction force, so small f1 is mu1 m1g, opposite to f1. T will be f1, capital F1 minus mu1 m1g, and f2 will be, since no acceleration, will be f2 minus t, opposite to f2. Similarly, if this is greater than this or this is less than this, then this will be trying to pull to the right, and this will be trying to pull the whole system to the right. So this reaches the maximum friction force first. So F2 will be mu to m2g. Okay, that friction force on the block 2 will reach the maximum value opposite to F2. Tension will be F capital F2 minus F2 max mu to m2g. Small f1 will be f1 minus t opposite to f1. This is the case. When both of them are equal, so both of them will be reaching the maximum friction force simultaneously. So f1 minus mu m1g is equal to f2 minus mu to m2g. So the small f1 will be reaching the maximum friction force opposite to capital F1, and small f2 also reach the maximum friction force simultaneously opposite to capital F2. And t will be, since they are same, so these are equal, so t will be f1 minus mu1 m1g or f2 minus mu2 m2g, either you which. So these are the cases, all cases considered. This last case, case 2 and of the subcase 4, and under the subcase 4, case ABC. These are very, very important. एक एग्जाम्पल लेते हैं भाई, ये देखो सेम, ये F1 F2 सेम डायग्राम I'm drawing it, light inestable string here. So M1, let's say 5 kg, mu1 is 0.3, m2 is 3 kg, mu2 is 0.4, f1 में 20 न्यूटन अप्लाई कर, ये पहले मैं रख दिया इसको सिस्टम को, देन आई स्टार्ट अप्लाइंग f1 f2, f1 फाइनली रीचेस 20 न्यूटन, f2 फाइनल रीचेस 15 न्यूटन। तो अभी बताओ ये तीनों पैरामीटर एक्चुअली ऑल द फोर एक्सीलरेशन f1 small f2 and t in this train. ओके, नेट ड्राइविंग फोर्स फर्स्ट सेक्टर से इट इज एक्सीलरेशन होगा कि नहीं होगा? फर्स्ट केस net driving force F1 minus F2 will be 20 minus 15, 5 Newton. But what is total maximum friction force? That is mu1 m1g plus mu2 m2g. That is coming out to be 0.3 into 5 plus into 10, 0.4 into 3 into 10. Take g as, let me say, take g as 10. Okay. G is 10 meter per second square. Okay, that's what I'm using here. Here G I'm using as mu1 m1g plus mu2 m2g is 0.3 into 5 into 10 plus 0.4 into 3 into 10. So that's coming out with 27 Newton is net, is the total friction force. Okay, so net driving force is 5 Newton, where F max total, I write here as F max total. This is the total maximum friction force. So ये कौन सी कैटेगरी में आएगा? Which category? Will be acceleration there? No, this one, the CD category, we discussed it too. This is the case one, when net driving force greater than maximum friction. But this is the case when net driving force is less than equal to total maximum friction force. This is coming under this case. This is 5, this is 27. So obviously coming under this. So then acceleration 0, ये कौन सा सब केस के अंदर आ रहा है? IV, क्यों? Because F1 is 20 and mu1 m1g 15. So F1 greater than mu1 m1g. Similarly, F2 15, but small f2 max is 12. So which case is coming? This most critical, F1 greater than mu1 m1g, capital F1, and capital F2 greater than mu2 m2g. इस कंडीशन में आ रहा है कि नहीं? Okay. Then under this fourth category, which ABC category में आ रहा है? Check that. F1 minus mu1 m1g कितना है वो? 5 Newton. F2 minus mu2 m2g, how much it is? 3 Newton. So it's coming at the 5 Newton, this 3 Newton, coming under case A. So obviously F1 is the maximum value. Put it here. F1 will be the maximum value, 15 Newton. So T will be capital F1 minus T will be this F1 has reached the maximum friction force. F1 is maximum friction force. We have discussed this now. So this is 20 Newton. This is maximum is 15 Newton. So tension will be 5 Newton. If tension is 5 Newton, then what is F2? ये 5 Newton, ये F2 is 15 Newton. So obviously, because no acceleration is equilibrium, so it is 5 Newton, 15 Newton. So this must be 10 Newton. So F2 is small f2 is capital F2 minus T, that is 10 Newton. So this is opposite to F2. Understood this? As in the diagram. Note that you see F2 is not equal to mu to mg. What is equal to mu mg? F1. F1 is equal to mu mg. Why? Because F1 minus mu1 mg greater than F2 minus mu to m2g. So small f1 will become, because this is greater than this. So f1, the small f1 is the maximum value of mu1 m1. Okay. Small f2 will not be equal to mu to m2g. As you can see, it is mu to m2 is 12 Newton, but it is only 10 Newton. Okay. In case I give a value of here F2 also 20 Newton, then this F2 minus mu2 M2G will be greater than F1 minus mu1 M1G, because it's, suppose F2 is 20 Newton. 20 minus this is 12, so 8, but this is 20 minus 15, it is 5. So 8 is greater than 5. So this will reach the maximum value fast. F2 will be mu2 M2G. This will come under case B. After that, the tension will be F2, capital F2 minus mu to M2G, and F1 will be F1 minus T. This will not become maximum. F1 will not reach maximum. So it's very simple. Am I clear? So ये सिचुएशन के बाद आपको कभी दिक्कत नहीं होनी चाहिए. पूरे सारे केसेस आप देख लो. ये तो इजी केसेस है, फिर भी आप देख लो, बहुत इजी रहेगा ये आपके लिए. And go through this video again and again. F1 minus F1 greater than mu1 M1G, F2 less than mu2 M2G. Obviously, this is the maximum friction force. Capital, say small f1 maximum friction force. After that, the whole thing is over. Understood this? But problem comes in these, the most critical case, on case 2, 4, and subcase 4 and subcase A, B, C. Am I clear? I think after this, any question, many questions are asked in this situation. You can handle every case. I have simplified this. If in case you are having any complication, you can always contact me in my, I have given everything, my contact and in my credentials. Okay? All of you clear? All the best for your upcoming examinations. Have a good day. Thank you all.